For millennia, we humans have gazed upon the night sky, seeking answers to profound questions about our place in the grand tapestry of the cosmos. Today, we embark on a journey to explore some of the most awe-inspiring, mind-bending truths the universe has revealed to us. Fasten your seatbelts, open your minds, and prepare to have your perception of space and time forever altered. Space is vast. Imagine the Earth, our home, a pale blue dot suspended in the void. Now shrink it down to the size of a grain of sand. On that scale, with our sun the size of a marble, the Milky Way galaxy would still span the entire continent of North America, and the Milky Way, just one galaxy among trillions, each containing billions of stars. It's a reality so enormous, so far beyond our everyday experience that it defies true comprehension. But here's the thing, that vastness shouldn't make us feel insignificant. Quite the opposite. It should fill us with a sense of awe and wonder. We are, quite literally, star stuff. Imagine a region of space where gravity is so strong, so overpowering that nothing, not even light, can escape its grasp. This is a black hole, a cosmic monster born from the death throes of a massive star. When a star significantly larger than our sun exhausts its nuclear fuel, it collapses under its own immense gravity. This collapse creates a singularity, a point of infinite density, where the laws of physics break down. Surrounding this singularity is the event horizon, the point of no return. Once you cross the event horizon, there's no turning back. Supermassive black holes, millions or even billions of times the mass of our sun, lurk at the centers of most galaxies, including our own Milky Way. These gravitational giants act as anchors, holding galaxies together and influencing their growth and evolution. Black holes remain one of the most mysterious and fascinating objects in the universe. We can't see it, we can't touch it, and we don't fully understand it. Yet it makes up a significant portion of the universe. This enigmatic substance, known as dark matter, has been puzzling scientists for decades. When astronomers observe the motion of galaxies, they find something peculiar. The galaxies are moving far too fast for the amount of visible matter we can detect. The only explanation? There must be some invisible form of matter, some unseen hand guiding the cosmic dance of galaxies. This invisible hand is dark matter. Dark matter doesn't interact with light, making it incredibly difficult to detect directly. But we know it's there. Its gravitational influence is undeniable, holding galaxies together. Scientists are conducting experiments to unlock its secrets. Our universe has a birthday. It came into existence an estimated 13.8 billion years ago in a cataclysmic event we call the Big Bang. In those first fleeting moments, the universe was an unimaginably hot, dense soup of energy and elementary particles. As the universe expanded and cooled, that primordial energy condensed into matter, forming the first stars and galaxies. The Big Bang left behind an echo, a faint afterglow of radiation that permeates the universe to this day. This afterglow, known as the cosmic microwave background radiation, is the oldest light in the universe. By studying it, scientists can measure the expansion rate of the universe and determine its age. Space is cold, brutally cold. Out here, the average temperature hovers around negative 455 degrees Fahrenheit, a mere 2.7 degrees above absolute zero. But why is space so frigid? Here on Earth, our atmosphere acts like a cozy blanket, trapping heat from the sun. But in the vacuum of space, there's no air, no atmosphere to speak of. It's essentially an empty void, devoid of the molecules that typically transfer heat. The sun radiates heat and light across vast distances, but this energy only warms objects directly in its path. In the vast emptiness between stars and galaxies, temperatures plummet to near absolute zero. Regions near stars are obviously much hotter, bathed in the intense radiation of these stellar furnaces. And then there are the extreme environments like black holes and neutron stars, where temperatures can reach billions of degrees. What if our universe, vast and awe-inspiring as it is just one of many? What if out there in the unimaginably vast expanse of existence, countless other universes exist alongside our own? This is the mind-bending concept of the multiverse. One of the most compelling pieces of evidence for the multiverse comes from cosmology. The cosmic microwave background radiation shows subtle temperature fluctuations across the sky. These fluctuations suggest that our universe may have interacted with other universes in the distant past. Quantum mechanics also hints at the possibility of multiple universes. The concept of the multiverse is still highly speculative, but it's a tantalizing possibility. In the vast expanse of the cosmos, there's a speed limit, the speed of light. Light travels at an astonishing 299,792,458 meters per second. But the speed of light is more than just a number. It's a fundamental constant in physics, woven into the very fabric of the universe. Einstein's theory of special relativity postulates that the speed of light in a vacuum is constant for all observers. This means that no matter how fast you're moving, a beam of light will always appear to be moving away from you at the speed of light. This concept has profound implications for our understanding of space and time. Time is relative, meaning that it flows at different rates for observers moving at different speeds. The speed of light also imposes limitations on space travel. Time, that relentless river that seems to carry us all forward at the same pace, is not as straightforward as we might think. In the realm of the cosmos, where speeds and distances are astronomical, time itself becomes a slippery concept. This is the mind-bending phenomenon of time dilation, one of the most counterintuitive yet profound consequences of Einstein's theory of special relativity. Time dilation tells us that time is not absolute, but rather, it's relative to the observer's frame of reference. Imagine two identical clocks, one here on Earth and the other aboard a spaceship traveling at a significant fraction of the speed of light. As the spaceship approaches the speed of light, time slows down for the clock on board relative to the clock on Earth. This isn't just a theoretical quirk, it's a real phenomenon that's been experimentally verified. The implications of time dilation are profound. The light we see from distant stars and galaxies has traveled for billions of years to reach us. Imagine a sphere so incredibly dense that a teaspoonful of its material would weigh billions of tons. This is a neutron star, the collapsed core of a massive star that has exploded as a supernova. Neutron stars are born from the death throes of stars much more massive than our Sun. When these stars exhaust their nuclear fuel, they can no longer support themselves against their own gravity. The core collapses catastrophically, compressing the star's protons and electrons into neutrons. The result is an object so dense that a single teaspoonful would weigh as much as Mount Everest. Neutron stars are incredibly small, typically only about 12 miles in diameter, but they pack a punch. They spin rapidly, often hundreds of times per second, and emit powerful beams of radiation from their poles. These beams, like cosmic lighthouses, sweep across the galaxy as the neutron star rotates. For millennia, humanity has gazed upon the starlit sky and pondered a profound question: are we alone in the universe? The search for extraterrestrial life has become a legitimate scientific endeavor. The universe is a vast place, teeming with billions of stars and planets. With such an abundance of worlds, it seems statistically improbable that Earth is the only planet where life has taken root. Scientists are employing a variety of strategies in their search, from scanning distant stars for signs of artificial radio signals, to searching for biosignatures in the atmospheres of exoplanets. The discovery of even the simplest form of life beyond Earth would be a monumental event. As we conclude our cosmic journey, we're reminded that the universe is not a static, unchanging backdrop, but rather an ever-evolving tapestry of wonder and mystery. Each new discovery, each mind-bending revelation, only deepens our appreciation for the vastness and complexity of the cosmos. The quest to unravel the secrets of the universe is an ongoing adventure, a testament to the boundless curiosity of the human spirit. As we continue to explore, to question, and to push the boundaries of our understanding, we can be certain that the universe will continue to surprise and inspire us. So keep looking up at the night sky with a sense of wonder, for within its depths lie endless possibilities waiting to be discovered.